You ever try and order pizza for a group of people? Some of the folks want pepperoni, some of them want Canadian bacon and pineapple, and it's hard to make everybody happy. In NSX, one of the tools we have at our disposal is the ability to deploy dynamic routing protocols. But do you want OSPF or do you want BGP? What's really important is being able to coordinate with your external environment. But it may be that you have both BGP to coordinate with internet service providers and OSPF to coordinate with other internal routers that you manage. And when you want routes to flow from one protocol to another, you're going to enable something called redistribution. And so in this nugget, we're going to jump right in and redistribute one dynamic routing protocol's table of information into another. So to dig into the world of redistribution of dynamic routing protocols, we're logging on to VMware's Hands-On Labs HOL 1903. We fired up Google Chrome. We're logging on to the vCenter server as administrator at vsphere.local with a password of VMware1! Now that we're logged in, let's go ahead and head down to networking and security. And dynamic routing protocols, of course, is the domain of routers, so we'll head to NSX edges. And let's take a look at our NSX edge, the perimeter gateway. We'll head to the Manage tab. Head over to the Routing tab. We can see it already has a router ID, and if we go down to BGP, we can see it's already set up with a BGP neighbor, so it's already learning information from BGP. Now what we're going to do is enable OSPF between the perimeter gateway and our distributed logical router, and by doing that, our BGP routers will be able to route all the way back to our virtual machines. So let's head to OSPF, and we'll head to Edit up at the top and enable OSPF. And we're going to enable default originate so that our distributed logical routers think of the Edge Services Gateway as their default gateway. We'll click OK. We'll publish changes. We'll head down to the area to interface mapping, click the green plus. And from the drop-down menu, we're going to choose our transit network and indicate that that belongs to area 0. Then we'll click OK. Then we'll publish those changes. And then under route redistribution, we're going to go ahead and enable route redistribution. So we'll click the Edit button up at the top. Enable redistribution for BGP is already turned on. And that's because NSX's deployment of BGP doesn't support the next hop self feature, which means in order to get even your own connected interfaces into the BGP protocol, we need to actually redistribute them into that protocol. So that's great. We'll cancel out of that. Down at the bottom, we're going to add another source of redistribution. So we'll click the green plus down at the bottom, and we're going to indicate that the learner protocol is going to be BGP and that it's going to learn from OSPF. Then we'll click OK and publish those changes. Now, why don't we need to reverse this process and also ensure that OSPF learns from BGP? Well, this router is functioning as the default gateway for our distributed logical routers, and so they'll know about their internal world and they'll know how to get up to the Edge Services Gateway, and that's really all the routes that they need, so there's no need to complicate their world with more information with specific networks that are all going to route through the same router anyway. So let's go over to that distributed logical router. Up at the top, we'll go back to networking and security. On the left-hand side, we'll dive into NSX edges. And this time we'll go into our logical router. Make sure we're on the Manage tab looking at routing. And we don't need to do any redistribution here, but we do need to make sure that OSPF is enabled. So we'll go to Global Configuration and ensure we have a router ID. We don't yet, so we'll click Edit and ensure that the transit network IP address functions as the router ID. That's perfect. And we can publish those changes. Now that we have a router ID, let's go down to OSPF. We'll need to add an area 0 definition. It doesn't exist yet, so we'll just type in area 0 and indicate it's a normal area. That's fine. Click OK. And then at the bottom, from the area to interface mapping, we'll click that green plus. From the drop-down menu, we'll choose 0. Indicate that the transit network is a part of area 0. And that's what will allow that area to participate so that it can share information. We'll publish those changes. Now with OSPF, we would want to add the other interfaces to the area to be able to support them being a part of the routing protocol, or we can quicken this process by going to route redistribution and ensuring that all connected routes are injected into OSPF. And you can see that's already been done here to speed up the process of getting the protocol up and running. So that looks great. Let's verify that our OSPF routing is functioning correctly. We'll head back to VMs and templates and let's just log into our routers. We'll expand region A1 and let's open up the perimeter gateway. And on the summary tab, we'll click the thumbnail to log into it. Spacebar to wake it up. Log in as admin with a password of VMware1! VMware1! And then let's type in show IP route. No routes here yet. Let's do show IP OSPF neighbor. And it's not showing up as an OSPF neighbor yet. Let's double check our configuration. Go back to the vSphere web client. You know what? Let's go back over to networking and security. And I've got a hunch I know exactly what happened. Let's go over to our NSX edges. And let's take a look at the newly configured logical router, or distributed router. Let's just double check our configuration. So again, settings, got our interfaces, all looking good, connected to the transit network at 5.2 and the CLI network, okay. Head to routing. Make sure those are published. Thought I'd done that before, we'll just double check. So we are redistributing connected routes in OSPF. In fact, that was already there, I didn't even change anything. If we go back to OSPF, we made sure that we had an area 0, and that area 0 is what the transit network was using, but you know what we didn't do? We did not enable OSPF. Notice its status is still stopped, so that was my bad. We'll click there in the drop-down menu for edit. We'll choose an interface for the transit network and put a check mark in to enable OSPF, and we'll set the protocol address to 192.168.5.3. Then click OK. And we'll publish those changes, and things should get a lot more exciting. Let's take a look at our perimeter gateway and see if it's updated yet. You can see we have a neighbor here. That's great, with show IP OSPF neighbors. And it takes a minute for it to synchronize their content. Let's do show IP route. And there we go. We've got a couple of routes now showing up, the 80 and 90 network. So now a device sitting out on the 80.0 network would be able to ping all the way to this device, but that's just enabling OSPF. The redistribution is what propagates that information out to other routers. So if we do show IP BGP, enter, there we go. And this lists all the networks that I'm willing to share in BGP upstream to the next router. And we can see those two originally sourced OSPF routes are now being propagated up to the BGP router. So now we can go from a device at 172.16.80.5. It can reach its default gateway at 80.1. That's the DLR. That DLR router has a transit network that connects it to the edge services gateway. That's 5.2 connecting to 5.1. Remember, 5.3 is the protocol address. These talk to each other using OSPF, but then this router connecting up to, let's say, the ISP router at 100.1, connected here locally to 100.2, they communicate using BGP. Well, now the knowledge of this 80 network is working its way all the way up to this level and can propagate beyond there as far as it needs to, because this router has been informed. So now if there's a server or access to the internet beyond that, to a network address translation server, whatever needs to happen, no worries, we've got end-to-end connectivity. The three main things that we can redistribute into a particular protocol are another protocol, like OSPF into BGP, like we just did. We also saw connected routes, taking essentially your interfaces and injecting them into the protocol, very important. And we didn't need to do it in this lab, but we can also take static routes that were manually configured and do just like we did with OSPF. Say, hey, here's a route that I know about. It was hand-coded in here, but hey, protocol, just so you know, here's what we're doing from this router onward. And that way that protocol can be dynamically informed and propagate that information beyond the scope of that protocol. My friend, I hope this has been informative for you, and I'd like to thank you for viewing.